Okay, in this podcast I'm going to go over the first 4 problems in the worksheet that I posted called Redox Introductory Worksheet. And I'm going to show you how to write half reactions. Identify which elements have changed oxidation number, and write the half reactions and then balance the overall equation. Okay, so it's always easy to identify the elements which have oxidation numbers that have changed if they are elements by themselves, because magnesium here is going to be a 0, and then magnesium any place else within a compound is going to be something different. In this case it's going to be a +2. And here I have hydrogen. It's an element by itself, so it's going to be a 0, and here it'll be a +1. So I've identified my 2 elements. Magnesium 0 becomes magnesium +2, plus I'm going to need 2 electrons here. And my hydrogen has gone from a +1 to, here I have an H2, so I have to make this 2H plus to a 0, and I'm going to need 2 electrons here. Okay, so the only place I need to, so I have 2 electrons lost, 2 electrons gained, so I'm balanced from an electron standpoint. I do have to raise this 2 here. Now let's identify what's reduced and what's oxidized. So the hydrogen, the oxidation number has gone from a +1 to a 0, so that is reduced, which means that the magnesium was oxidized. Alright, here I have, again, element iron is a 0 here. Here it's a +3. So iron, 0, goes to iron. This is a 2 iron, so I need to put a 2 there, and it's a +3, which is a total of +6 electrons from 0, so I need 6 electrons here. In vanadium, here it is +3. In vanadium here, and I need to put a 2 there, is going to be a +2. And so what I have here is 6 electrons, 4 electrons, so I'm going to need 2 here. Okay, so first of all, what's been reduced is my vanadium. It went from a +3 to a +2, so that's reduced. And my iron was oxidized. I have 6 electrons being lost, so I need to multiply this times 3 to get the electrons lost and gained to be the same. Alright, so now I can raise my coefficients. This is going to be in front of the vanadium. And 3 times 2 is 6 here. Now we want to do an inspection to see if we are balanced. I forgot to bring this 2Fe up here. So I have 2Fe, 2Fe, 6 V's, 6 V's. 3 times 3 is 9. 3 plus 6 is 9. So voila, that's good. Alright, this one's a lot more complicated. Okay, so I got to figure out which elements are affected. And usually if I have an element, an ionic compound with a polyatomic, it's usually going to be the middle guy. But let's see. So this sulfur is part of a sulfate, and within a sulfate, the sulfur won't change charge. So it's not the sulfate. So it's got to be the manganese and the nitrogen. So let's take a look. Manganese, oxygen is each is -2. That's -8 plus 1. So this is a +7. A sulfate ion is a -2, so the manganese must be a +2 here. Okay, this was a 7. So we need 5 electrons here. Alright, so the nitrogen goes from -4, that must be a +3, to a nitrogen +5. And I need 2 electrons here. Okay, so what's been reduced is my manganese, and my nitrogen's been oxidized. And I know manganese is reduced because it goes from a 7 charge to a 2 oxidation number, and that number has been reduced. Okay, so let's balance the electrons. I've got 5 here, 2 here, so I've got to multiply all of this by 2 and all of this by 5. And when I do that, I get 2 in front of the KMN, 2 in front of the MN here. I'm going to have 5 in front of this nitrogen-containing compound and 5 in front of this nitrogen-containing compound. Alright, so let's take a look at what we have and see if we need to balance anything else. So first of all, I have 2K here plus 5K here, that's 7. I have 5K plus 2K, so the K's look good. The manganese, I have 2 manganese and 2 manganese. That looks good. I have 5 nitrogen and 5 nitrogen. Okay, so let's take a look at the oxygens and then we'll look at the hydrogens. And those are always the two I suggest you save for the last. So here I have 2 times 4 is 8 oxygens, 5 times 2 is 10, and I have 4 here. Oops. So it's 8, 10, and 4. Actually, before we do that, let's look at the sulfur. I have 1 sulfur, 2 sulfurs, so I need to double this, okay? So I'm going to have 2 times 4 is 6, is 8 here. So I have 8, 10, 8, that is 26 oxygens on this side. On this side, I have hold the phone. So I have 2 sulfurs here plus 1 here. So this is 3 sulfurs. So 3 times 4 is 12 here. So it was 8 plus 10 plus 12, which is 30. Alright, I knew I'd done something wrong there. And let's take a look on this side. So I have 2 times 4 is 8. I have 1 here. I have 15 from potassium nitrate. And I have 4 here. So let's see what that adds up to. 19, 28. So I need 2 more. So I'm going to make this 3 waters, and in doing so, now I'm up to 30 oxygens, and let's see if my hydrogen match now. 3, that's 6, that's 6. So I can finally say, voila. Let me just check this versus the answer key. Yep, that looks good. So it took a lot of back and forth, but what we got there takes some work sometimes. Alright, here's another pretty complicated one. Alright, so just by inspection, I suspect chromium, and I'm going to suspect tin. Okay, so I have Cr2, and this is a minus 14 from the oxygen, plus 2 here, so this is a plus 12. So each of these is a plus 6. Going to Cr, I'm going to put a 2 in front to match this 2 here. That's going to be a plus 3. So that's 12. This is 6, so I need 6 electrons here. Okay. Now the tin goes from a tin plus 2 to a tin plus 4, and I'm going to need 2 electrons there. Okay. So this has been reduced. This has been oxidized. And I know I have to balance my electrons. So this is 6 electrons gained, 2 electrons lost, so I'm going to multiply all this times 3. Alright, so I'm going to bring up my coefficients. That's a 3. That's a 3, and I need 2 here. Alright, so let's see where that puts us. So I have 2 K's here, so I'm going to go ahead and double this KCl, make that 2, get my K's alright. My CRs look good. My tin, I've got 3 here and 3 here. My CLs are not where I want them to be. So this has 6 CLs. Right now I have 2 times 3 is 6 here, 3 times 4 is 12 here, plus 2 here. That's 14, that's 20. Okay? So if I have 6 here, I'm going to need 14 here to get my CLs right. Okay? And if I do that, then let's take a look at what happens with my hydrogens on the other side. So I have 14 hydrogens here. I have 2 here, so I got to make that 7. And Now let's check the oxygen. So the oxygen, I got 7 oxygen, and I think I am done. Okay, so that looks like everything's good, and we're going to stop right there.